So we're going to use SPSS to do an independent groups t-test to show you how we got some of these numbers without having to do any of the math, right? SPSS allows us to do that. So what I've done is in the variable view of SPSS, I've created my two variables. I've got my independent variable, which are my groups, and if I look at my treatments, I have two groups. I've got my treatment group and my control group, and I've set that up as a nominal variable because we're naming things, we're putting them into groups. And then I've got my second variable, which is a dependent variable, and this is the memory score, and this is a scale value. So when I go to my data view, remember in SPSS, the numbers on the side correspond to different people. So each one of these is a different person in our sample. So the first 10 I've put in group 1, which is our treatment group, and the next 10, 11 through 20, I've put in group 2, which is our control group. From there, we've got the memory scores in the right-hand column here. So what we're going to do is we're going to analyze these scores. So I've got everything put in. I've got my 20 participants. I'm going to analyze these, and I'm going to compare the means, because that's what I'm doing here. I'm comparing the means, the t-test. I'm looking for the difference in between the means to see if something significant has happened. I'm going to do an independent samples t-test because I have two different groups of independent samples. And what I've done here is I've put the memory into the test variable and my groups into the grouping variable. If I were to go to options, I could put a 95% confidence interval. I could change that, but I do want it to be a 95% confidence interval because that's pretty standard. 0.05 is generally the alpha value for significance. So I'm going to go ahead and click OK, and I get my outcome. So in the top, I've got my descriptive statistics, and you can see that I've got 10 people in each group, 10 in my treatment group, 10 in my control group. The mean is 13.10 and 9. Those numbers should look familiar. And you can also see that I've got the standard deviation calculated. That helps us to determine the variance, remember, and the standard error of the mean calculated. Now, we aren't going to need to use those because SPSS is going to do all of the calculations for us. Looking at the bottom results here, what we can see is, first of all, SPSS calculates the t-test in two different ways. The first way is if it assumes that equal variances between the two groups. If there is an equal variance assumed between the two groups, like we have in this one, remember we looked at the histograms earlier, then we're going to use the equal variance row. So we're going to use the top row here. If there is not an equal variance assumed, so like in the second example that we showed in the PowerPoint, then we would use the bottom row here. But we are going to assume equal variances. So SPSS is saying, all right, we're going to assume the equal variance. So we've got a t-score of 3.3. The degrees of freedom is 18. And the reason it's 18 is because, remember, degrees of freedom is -1 for each of the two groups. We're looking at a two-tailed test here. So with this particular t-test, we're not saying whether or not we are going to expect the difference to be positive or negative. It can be either direction, so that's 0.004. So what we want, and remember we reported a significance, a p-value of 0.002. The reason we did that is because we cut it in half, because the p-value is only 1/2 of that 0.004. We're expecting it to be a positive result in the t-test. So we're going to report a p-value of 0.002. The mean difference is 4.1, just like we reported earlier. There's a standard error of 1.242. Remember, we're going to divide that out. That's what we looked at earlier. That's the noise. Okay, so that is the variance within groups that we want to get out of there so that we can understand what's going on. And then here's our 95% confidence intervals. We have about 1.49 or 1.5 as the lower value, up to about 6.7 is our 95% confidence interval. So we can be 95% sure that the real value falls somewhere in that range.